Let's take a look at number 16 here. This is part 4. We're going to change 7.8 miles per hour into kilometers per second. So we're going to start off by writing what we're given, 7.8 miles. Anytime I've got a per something, that means to me a fraction, so per 1 hour. So it means in 1 hour, travel 7.8 miles. Now we're going to convert this to kilometers per second. Again, we got a two-steppers here. We got to either change miles to kilometers first or hours to seconds first. It really doesn't matter what you do. So let's just change hours to seconds. So there are, in 1 hour, there are 60 seconds. And let's convert, there's 60 minutes. And now let's convert in 1 minute into 60 seconds. So that's going to get my hours out of there. That's going to get my time into the units I want. That's going to be per second. And now let's convert these miles to kilometers. So I've got a couple of conversion factors here. I'll give you any conversions that you need. So we've got 1 mile. We want to put this down below, so our miles are going to cancel. Is equal to 5,280 feet. That gets me to feet. Now I'm going to get feet into inches, which is going to help me to get them into centimeters. So in 1 foot, there are 12 inches. And then in 1 inch, we have 2.54 centimeters. Now we want to go to kilometers. There are 100 centimeters in 1 meter. And there are 1,000 meters in 1 kilometer. So let's just double check our units. Our hours are going to cancel. Our minutes are going to cancel. We're going to be left with seconds. Miles are going to cancel. Feet are going to cancel. Inches are going to cancel. Centimeters are going to cancel. And meters are going to be canceled. We're going to be left with a kilometer over a second. So that's going to give me my kilometers per second. So if I do this, we're going to end up with 0.0035 kilometers per second. So that's number 16. Take a look at number 17. This one's just like this, except we're going to introduce this density term and use it as one of these conversion factors. So I want to know how many kilograms of methanol does it take to fill a 19.5 gallon fuel tank of an automobile modified to run on ethanol. And this is a little handy piece of information down here. So we're going to take 19.5 gallons, and we want to convert gallons in this case to liters. So 1 gallon is 3.785 liters. This is going to be my answer in liters, but I don't want it in liters. I want it in kilograms. So now I got to find a way to convert a volume measurement, liters, into a mass measurement in grams, and that's where our density comes in. And this is grams per milliliter, so I got to do one more step. I got to change liters to milliliters. There are 1,000 milliliters in 1 liter. Okay, so my liters are going to cancel. I've got it in milliliters. Cool. So now let's go to look at our density. We know that 0.791 grams of methanol takes up 1 milliliter. So now our milliliters are going to cancel. Now I have it into grams. But I don't want it in grams again. I want it in kilograms. But that's an easy enough thing to do because I know that there are 1,000 kilograms in, 1,000 grams in 1 kilogram. So I'm just going to multiply everything across the top, finally divide by 1,000, but if you notice we've got 1,000 above and 1,000 below, so let's just cancel the thousands out. It's going to multiply 19.5 times 3.785 times 0.791, and this should give me 58.4 kilograms. Whoops. That's a 5 there. I buried it. Let's see. Let's take a look at this last one here. I'm going to go 78.2 cubic meters of ethylene glycol, and I want to change it to milligrams. So I've got cubic meters. I've got a density of grams per milliliter. So what I'm going to probably want to do is change cubic meters into cubic centimeters. So what I'm going to do first is take 1 meter is the same as 100 centimeters. But if I do this 3 times, that's the same as cubing that and cubing that. And now let's do our next step here on our part 5. We're going to finish this up in the next video.